In this video, in the Universe Sandbox simulator, I'm terraforming the largest moon of Jupiter and the entire solar system, Ganymede. This time, I won't turn the sun into a red giant. Instead, I'll terraform Ganymede in the present time and in its native orbit, which is Jupiter's orbit. And let's start with an interesting feature of Ganymede. It's the only moon in the solar system that has its own magnetic field. Here, you can see, and the strength of this magnetic field is 7.5 milligauss. And first of all, I'll create an atmosphere on Ganymede suitable for life. At the moment, there's a tiny amount of oxygen in Ganymede's atmosphere. Preparing for this video, I created special asteroids with a large amount of nitrogen in their composition, as well as carbon dioxide and oxygen. And in my case, for terraforming Ganymede, it'll be enough for me to launch 20 objects with nitrogen. I'm launching them at different parts of the moon so that the gas is spread evenly through the atmosphere right away. Six objects with oxygen, and one object with carbon dioxide. Everything has landed, and as we can see, clouds have already appeared on Ganymede, and we see that oxygen, carbon dioxide, and nitrogen have appeared in Ganymede's atmosphere. And also, many of these elements are in liquid form on the surface of Ganymede. I'll speed up time to 3 months per second, so you can watch how the liquid elements evaporate and saturate the atmosphere on Ganymede. Well, as we can see, this process is very slow. I won't risk speeding up time any further, so to avoid waiting, I'll simply evaporate all the liquid from Ganymede's surface into the atmosphere. And it turned out something like this. Now I'll take and evenly distribute all the gases across the surface of Ganymede, and it turned out to be something like that. There's a relatively dense atmosphere. By the way, I'll check the pressure, and the pressure, by the way, is already excellent, just over 1 atmosphere. But guys, since we're far from the sun, the temperature here is very low, currently minus 162 degrees Celsius, and to warm up Ganymede, I'll have to do something. Here, for example, is the average albedo parameter. I'll set its value to 0.26, and I'll have to set the number of atmosphere layers to as many as 35. Otherwise, Ganymede simply won't warm up. But the main thing is that from all these manipulations, the surface pressure hasn't changed. Now 3 months per second are passing again, and let's see how Ganymede will melt. By the way, it already has a lot of water in its composition, so I won't have to add water separately, which is already great. And I'll also hide the atmosphere in clouds. It'll be more comfortable for you to watch how the surface of Ganymede changes. Well then, you saw how Ganymede melt in it. The average temperature on it right now is 2 degrees Celsius. Well, we still have to wait a long time for the entire climate on Ganymede to stabilize. I'll do that off camera so I don't drag this video out too long. But for now, let's take a look at what exactly has happened. As we can see, a lot of liquid water has appeared, and there's even vegetation on the surface now. If we turn on the atmosphere and clouds, this is what Ganymede looks like now. And here it is against the backdrop of Jupiter. Well guys, after some time, this is the Ganymede we ended up with. We can see a vast ocean, and if we hide the atmosphere and clouds, we can see islands with life. The poles here have these large ice caps. The moon turned out to be quite cold. The southern hemisphere has even more ice. Only the equator and middle latitudes are ice-free. Overall, right here, you could say there's one continent like this. On this side, there are these islands, but in this part of Ganymede, there are almost no islands. Only in the southern part is there a little bit of land. So overall, this is the terrain the moon ended up with. If we turn on realistic lighting, Ganymede looks a bit dim because of its distance from the star. Now let's look at its final characteristics. The average temperature is 4 degrees Celsius. The atmosphere has 22% oxygen, 0.366% carbon dioxide, 4.5% water vapor, and 73% nitrogen. And there are liquid oceans and ice from water. The surface pressure is just over 1 atmosphere. The greenhouse effect effect is 167 degrees. Yeah, I had to make it huge because there was no other way to heat Ganymede up. And so in the end, the likelihood of life on such a moon is only 12%. I have an idea. Let's try to maximize the likelihood of life on Ganymede. I'll make it brighter. It'll look nicer this way. Well, I think the main reason the likelihood of life is so low is Ganymede's mass. It's very small. But if we give Ganymede 1 Earth mass, whoa, look how much it grew instantly, guys. And its radius became 35% larger than Earth's. And the likelihood of life dropped even further. Even like that. Maybe the magnetosphere's weak now. Let's see, if we set the magnetosphere strength to 1 Gauss. Now that's a very powerful magnetic field. That didn't affect the likelihood of life. Maybe the temperature's too low. What if we set the average temperature to around 15 degrees Celsius? Now, the likelihood of life hasn't changed. Oh, that's the problem. The pressure here is now 15 atmospheres. Okay, I'll adjust it to 1 atmosphere. Well, the likelihood of life only went up a little bit. Maybe there's too much carbon dioxide in the composition. I'll reduce its concentration tenfold. And let's also check the motion. Let's even give Ganymede an axial tilt. I'll set it to a near-Earth value of 23 degrees, and I'll make the day length 1 day, just like Earth. Yeah, it's tidally locked to Jupiter, and will eventually become tidally locked again. But for a short time, it can rotate like this, and we can see if it affected the likelihood of life. Well, only 2%. What is going on? Well, let's also set Ganymede's density to be the same as Earth's. There, now everything matches Earth, the radius, the mass, and the density. And voila! Look, the life likelihood percentage immediately rose to 28%. And maybe I should add a little more land? I'll decrease the amount of water. Here, let's say if there's even more land on Ganymede. 28% life likelihood. Ow, the pressure somehow went up again. Let's try 1 atmosphere again. And look at that jump. 72.5% life likelihood. But the land disappeared, only water is left. Bring in the land back. Adjusting the pressure. By the way, I adjust the pressure and the land gets flooded. How can that be? I'll try to decrease the amount of water here. It won't even let me decrease it. Anyway guys, the simulator decided to tell me not to touch the water, but a few islands with life remain here, and the poles, as we see, are frozen. The temperature is normal. Turn in the atmosphere and clouds back on, and we see that the life likelihood is already 87%. Well, I think this is the best result I'll be able to achieve in this video. And by the way, on these small remaining islands, we see that there are even city lights at night. An advanced civilization is already present here. Anyway guys, I went back to the Ganymede I originally had. This is how it looks against Jupiter. Well, to me, this Ganymede looks much nicer, but unfortunately on this specific Ganymede, there's no advanced civilization. I don't see any city lights at night, and overall, this is how I managed to terraform Ganymede. Write in the comments what you think of my terraforming, correct any inaccuracies, and also don't forget to like my video. Thank you very much.